Hello everyone. Welcome back to my channel. In the last class we have discussed there are two important basics as a part of the Super 6 basics. One is the atomic mass, second one is the atomic number. So in this class I think we have done and atomic numbers from 1 to 30 elements with a simple shortcut, and we have also completed the atomic masses with two simple shortcuts we have done. Now we are moving to the third part. So we should remember one thing: if we are clear with the atomic numbers and the atomic masses, then you are able to learn this simple electronic configuration, especially atomic number. As we know that atomic number is represented with Z and atomic mass is represented with A. And this atomic number we have to just then remember to know the number of protons. For the simple then elements, then number of protons are always equal to number of electrons. So you have to remember this point. That's why atomic number is more important. So in this class we are going to discuss about our third basic, that is 1 to 20 elements simple electronic configuration. So we have to know that first of all, what do you mean by the simple electronic configuration? With a simple trick we are going to learn the simple electronic configuration. We have to understand each and every basic from the starting, then you can understand this also. But to understand the simple electronic configuration, we have to know certain basic more elements. We have to learn even more other than important concepts. Once if you understand that concepts thoroughly, then you can understand the simple electronic configuration. So let us see what are those simple then concepts. So as we know that, as I mentioned, then atom is having, there are two important then things are there. So atom is having electrons, protons and neutrons. In every atom there are three subatomic particles are there. So means subatomic particles. Subatomic particles are nothing but the part of the, they are the part of the atom. When you divide atom, so the atom is divided into three parts. One is the electron, proton and neutron. So in this, among these three, the protons and neutrons, they are present in the nucleus, and electrons are present in the extranuclear part. So nucleus means when you divide the atom, so the center of the any particular then the center of the atom is called as nucleus. In this nucleus, these positively charged particles, they are the protons, and without any charge, we know that protons are having positive charge, neutrons are having neutral charge, there is no charge in this, and electrons are having the negatively charged particles. As protons and neutrons are present in the nucleus, the protons and neutrons together itself we called as nucleus. In the extranuclear part, so we are having then other than then protons and neutrons, these protons and neutrons then apart from that we are having the electrons which are present in the extranuclear part. So extranuclear part is nothing but other than nucleus. This extranuclear part is divided into some imaginary paths. These imaginary paths are called as orbits. So these are called as orbits where the electrons are revolving. So now let us see somewhat then more information about this. So as we know that electron is represented with small e and its charge is 1 unit negative charge, and it is discovered by J.J. Thomson. It is very much important who discovered and what is its charge also. The protons are represented with P, and these protons are having positively charged 1 unit positive charge, and it is discovered by the E. Goldstein. And nucleus, neutron is represented with N, and as it is neutral, then there is no charge, then we call it as a neutral one. And James Chadwick, it is discovered by James Chadwick. Present, like as I mentioned, so electrons are present in the outside of the nucleus, that is called as extranuclear part, and new protons and neutrons, they are present in the, so then in the nucleus. And apart from the previous one, then a little bit extra information. This slide is having little bit extra information. That is that -1 unit charge is nothing but exactly minus 1.602 into 10 to the power minus 19 coulombs. Exactly opposite will be the positive charge. As we have discussed, it is the +1 charge, plus 1.602 into 10 to the power minus 19 coulombs. Exactly, protons and neutrons are exactly the same amount of charge, same quantity of the charge with opposite. But when it comes to the mass, so this mass of the proton, this electron is equal to 9.11 into 10 to the power minus 9, 31 kgs. Means when you take minus 31 is nothing but after, then point, if you keep 31 zeros, means almost 1 by 1840 times of the particular atomic mass unit in comparison with the protons. But when it comes to the, then protons, its mass is 1.6 into 10 to the power minus 27 kgs. These two are also very much important for us. And when it comes to neutrons and protons in terms of mass, protons and neutrons, they are having almost 1 unit mass. In terms of charge, electrons and protons are having similar amount of the quantity of the charge with opposite signs. And when it comes to the next part, as we have discussed this Bohr's atomic model, according to the Bohr's atomic model, to understand the little bit more information about the Bohr's atomic model, to understand the simple electronic configuration, we have to know Bohr's atomic model. This Bohr's atomic model is saying that atom is having two important parts are there. So that is, one is the nucleus. So that nucleus is having positively charged particles, and also neutrons are also present in this particular one. But at this particular time, we have to know that only positively charged particles. And when it comes to these positively charged particles are concentrated in the center of the nucleus. And this Bohr's atomic model, so by the Niels Bohr in 1913, introduced one of the unique concept that is called as orbit. So now the imaginary paths, whatever they are present, the circles, so whatever they are present around the nucleus, these imaginary paths we are calling it as orbits. So these orbits are also called as energy levels or the shells. And each and every orbit is having a fixed amount of energy. That fixed amount of energy we called it as quantized energy. That is called as quantized energy. So there is a change when if electrons are present. We know that electrons are present in fixed in number of, then electrons are present in each and everything. But when electrons are jumping from one energy level, means from one energy level to next energy levels, so then there is a then change in the energy levels. But when the electrons are present within the same shell, there is no change in the electrons. Then there is no change in the energy levels. These orbits are represented with K, L, M, N letters. That is called as K, L, M, N. One orbit is represented with one letter. Here the reason for taking then K here is, it's simple that instead of then taking in similar manner from A, B, C, D, then to make it very much unique. And also in Sanskrit, K stands for Kaksha. Kaksha is nothing but path. So it is also represented with n values. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Now you can say that the first orbit is nothing but K, that n value is equal to 1. Second orbit is nothing but L, n value is equal to 2. Third orbit is equal to M, n value is equal to 3. So the any particular atom is called as the valence shell, and the second last shell, it is called as the penultimate shell, valence shell and penultimate shell, and third last shell is called as the anti-penultimate shell if it exists. The third last one is called as the anti-penultimate shell. And if there are three shells, but among all these shells, every atom is having one shell, that is called as the then outermost shell. This outermost shell electrons decides valency, chemical properties, and also the other charges also. Now let us know that valency is nothing but the number of electrons which are gained or lost by an atom. So there are two important definitions which we have to know. The number of electrons present in the last shell is called as then valence electrons. Then valence is nothing but number of electrons are gained or lost by an element is known as valency. This is very important to decide the charge, to decide the chemical properties, to decide the metallic non-metallic nature as well. Now let us come back for the simple electronic configuration. Now come back to the final part of this one. Means to understand what is electronic configuration, we have to know that what do you mean by the shell also, orbit also, nucleus also, subatomic particles also, and how are they arranging also, each and everything we have to know that. So then we can just understand very clearly. Now come back to this. Now we know that very clearly. So we know that very clearly. So the electrons and protons, so like then protons and neutrons are present in the nucleus. There is no confusion with the protons and neutrons. But apart from that, electrons are present. For electrons, there are many options are there. So that's why what happened, these options we called it as like then, so there is a then arrangement of the electrons should takes place. Some scheme is required. First one, let us see the definition of the electronic configuration. The arrangement of electrons in the various shells of an atom in an element is known as electronic configuration. Arrangement of electrons in the various shells of an atom is known as its electronic configuration. So the number of electrons, like then the number of electrons present in every shell, the maximum number of electrons present in a given shell is decided by the Bohr-Bury scheme. That Bohr-Bury scheme is nothing but saying that the maximum number of electrons present in a given atom, in a given shell, is equal to 2n square. Previously we have discussed what do you mean by n. Now n is nothing but shell number. It means if you want to know the first shell, so then you have to substitute n is equal to 1. Then number of electrons present in the first shell is equal to 2. If you want to know the second shell capacity, you have to substitute n is equal to, then you are going to get 8. If you want to know the third shell capacity, then you have to substitute n is equal to 3. Then the maximum number of electrons will be 18. In the similar manner, if you want to just know the then fourth shell capacity, 32. Now we come to a conclusion that the maximum number of electrons can be calculated for simple electronic configuration from Bohr-Bury scheme. That is 2, that is for the first shell, that is called 2n square, and for the second shell it is 8, third shell it is 18, fourth shell it is 32. Now accordingly if I fill it as I know that, so the first shell is nothing but then its capacity is 1. So that's why hydrogen is having only one electron. So if atomic number is 1 means number of electrons are also 1 for the neutral atom. That's why we know that the first shell capacity is equal to 1. So 2, that's why it goes to first shell. The second element is having 2 electrons. Then its capacity is like, then as first shell capacity is 2, still we can accommodate in the first shell. With these 2 elements, the first shell, that is K, is filled. Now if you have more than 2 electrons, out of 2, out of 3, 2 of them they are present in the first shell. The remaining element, the remaining electron will move to the second one. We know that the second shell capacity is maximum is 8. Till we reach 8, the all other electrons will go to second shell only. Once if we reach 8, second shell is also finished. Then now if you have more than 10 electrons, out of 11, 2 of them you can fill in the first shell, and 8 of them you can fill in the second shell because its capacity is 8. Then the 11th electron will move to second, then third shell. We know that the third shell, like, then capacity is 18, but we can fill maximum, like, then 8 electrons only. So the ninth electron is moving. Though the third shell capacity is 18, but only 8 electrons are accommodating, but the ninth electron is moving to the fourth shell. So that's a reason simple electronic configuration is applicable only up to 18. It means till argon it is applicable. Okay, so with this we have just then concluded that, so the simple nothing but, so we have to fill the electrons according to the shell. In this class we have discussed what do you mean by subatomic particles, what do you mean by the, like, nucleons, and where the electrons will be present, where the protons are present, where the neutrons are present. Protons and neutrons are present in the nucleus, and electrons are arranged in the various shells, that is called electronic configuration. To know the capacity we have used Bohr-Bury theory, that is very important. According to Bohr-Bury theory, the maximum capacity of any shell is equal to 2n square, and when you substitute n is equal to shell number, you will get its capacity. So first shell capacity is 2, second shell capacity is 8, third shell capacity is 18, and fourth shell. But after 18, the electrons are not following the Bohr-Bury theory, that is simple electronic configuration. So this particular simple electronic configuration is applicable only up to 18 electrons. So that's all for the today. So thank you very much for listening to my lecture, and still if you have not subscribed my channel, please subscribe and share this all these then classes to every student, every place. These all are very very important starting from 8th class to till so many competitive exams, especially for NEET and JEE mains. If you are studying long term directly, these all basic classes will help you a lot. So thank you so much.